using a table of values or something like that. We haven't done a lot of graphing for a while, so we need to kind of cover that again and make sure we understand how to do it. So here we go. So a table of values is something like this. It has the x values, the y values, or the input and output values, and then also something that would indicate what they look like when they're paired together as an ordered pair. So here's kind of an example of one that goes with the function y equals x plus 2. And by drawing a line through all of the points, you graph all of the solutions of that particular function. Okay, so let's check out a couple. So here's a function right here. It's actually written in the form of y equals mx plus b. So let's go ahead and calculate the output. So if the input is -1, to find the output, what we will need to do then is just, we find out that the output would be -1 plus 1, which in this case would be 0. For the next one, the input would be 0 plus 1, giving us an output of 1. For the third number that we have in our list for inputs, we would have 1. Then we would add 1 to that, getting an output of 2. And then thirdly, 2 plus 1 equals 3. So these are the inputs and outputs for -1, 0, 1, and 2 for your input. And then these would be the corresponding outputs. So now we're going to graph them. So -1 and 0. So -1 and 0. 0 and 1. 1 and 2. And 2 and 1, 2, 3. 2 and 3. So there would be the dots that we have indicated right there. So if we use a little line tool, draw a line up through those, it looks something like that. So that's not too hard to do if you think about it. So let's try a couple of others here. So moving along to the next slide. Here's our next function, y equals -2x plus 1. They've given us -1, 0, 1, and 2 to be our inputs. And we're going to calculate our outputs. So here we go, -2 times our input of -1. And then we'll add 1 to the result. Let's go ahead and set all of those up while we're at it. So -2 times 0 plus 1. -2 times 1 plus 1. And -2 times 2 plus 1. So as we go through here, let's calculate our outputs. -2 times -1 is +2. +2 plus 1 is +3. -2 times 0 is 0. 0 plus 1 is 1. -2 times 1 is -2. -2 plus 1 equals -1. -2 times 2 is -4. -4 plus 1 would be -3. All right, let's go ahead and graph those then. -1, 3. So -1, 1, 2, 3 would be our first point. 0 and 1 would be our second point. 1 and -1 our third point. And 2 and -3 our fourth point. Grabbing our line tool once again, stretching it down through there. And that would be the graph of that particular function. All right. So let's move on here. Okay. Let's look at this particular one. On this one, they did not give us an input or an output. I've got a little interference on the screen. So let's come up with some inputs and outputs. So we got X and Y. Let's put in -1, 0, 1, and 2 for our inputs and calculate our outputs. So our outputs would be y is going to equal whatever happens when we multiply the input by -3. So -3 times -1 equals 3. -3 times 0 equals 0. -3 times 1 equals -3. And -3 times 2 equals -6. So let's graph those. -3 and 3, so 1, 2, 3, 1, 2, 3. Oops, -3, +3. Almost went the wrong direction. 0 and 0. Oh, I made a mistake. It's -1 and 3. So you got to watch when you're doing that. I just kind of look at the wrong number. So when you're graphing these, be really careful. So a -1 and 3. So -1, 1, 2, 3. First point. Then the next one is at 0, 0. Then the next one would be at 1 and -1, 2, 3. And then at 2 and down 6. So there's our next graphed line right there. Okay, moving right along. How about this particular function? Let's put in the numbers that we want to find an input-output for. And 3x plus 2 is the function here. So y is equal to that. So if we put in -1, 0, 1, and 2, because they look like they would be very easy to work with, let's try that out. So we're going to have 3 times -1 plus 2. 3 times 0 plus 2. 3 times 1 plus 2. And 3 times 2 plus 2. So when we calculate that out, 3 times -1 is -3. -3 plus 2 is -1. 3 times 0 is 0. 0 plus 2 would be 2. 3 times 1 is 3. 3 plus 2 is 5. And 3 times 2 is 6. That is a 2 there. 3 times 2 is 6. 6 plus 2 would be 8. So if we graph these, our first point would be -1, -1. That would be right here. Then 0 and 2, which would be right there. And then 1 and 5, so over 1 and 1, 2, 3, 4, 5. So I'm checking a 0. Yeah, 0 and 2, 1 and 5. Let's check that first one. Oh, I messed up on that first one. Remember, it was -1, -1. And I noticed that my points were not lined up here. So I've got to go back and regraph that first one. -1 and -1 and -1. That's more like it. And then the last one, 2 and 8. So over 2 and up 1, 2, 3, 4, 5, 6, 7, 8. So when I do that, now I can grab my line tool, come down through there, and you can use your ruler to graph these as well. So there's the graph of that particular function. So the number, here's a real world example. The number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by the car. Write and graph a function that describes the relationship between gallons and pounds. Okay. All right, so the way this function is going to look when we write it, well, you can even type it in there. We're going to write down that the number of pounds of carbon dioxide produced is equal to 20 times the number of gallons used. So when we put in our input, we're going to have an input of gallons and an output of pounds. So let's try a few numbers then. Let's grab our marker here. If we put in 1 gallon, then the pounds is going to be 20 times 1, which equals 20. If we put in 2 gallons, that will be 20 times 2, which is 40. What if we don't put any gallons in? Then it would just be 20 times 0, which is 0. So there's a good enough set of data that we can graph it. So what we're going to do, we get to choose the scale here. So as we choose the scale on our graph, keep in mind what kind of numbers we have here. So if this is 0 gallons, 1 gallon, 2 gallons, 3 gallons, and so on, then as we go up the side, we've got to decide where to put the pounds. So let's say that every line going up represents 10 pounds. So 10, 20, 30, and 40. So we can be very flexible about how we do our scale based on the data that we're given. Okay, let's go ahead and graph our points. So when we do that, our first one is, well, let's start with the 0, 0, 0 gallons, 0 pounds. 1 gallon, 20 pounds. 2 gallons, 40 pounds. And you can start to see the line take shape there. So we'll grab our line tool, come up through there. It's going to look something like that. And you can actually use this line to actually predict how many pounds you'd get out of an alternate amount of gallons in your examples. All right, so let's just see how many more gallons. We've got one more example to do. So the distance m in miles traveled by a car is 35 times the number of gallons of gasoline used by the car. So let's do that, write the function again. So the distance miles in miles traveled by a car is 35 times the number of gallons. So miles equals 35 times the number of gallons used. So our input here is going to be gallons, and our output is going to be how many miles we drove. So we got those in place. And now we can go ahead and put some inputs in. So let's start out with, what if we put in 0 gallons? It's pretty straightforward. So 0 gallons. So that would be 35 times 0, which is 0, right? What if we put in 1 gallon? That would be 35 times 1, or we'd go 35 miles. If we put in 2 gallons, that would be 35 times 2, or in other words, 70 miles. We could go on 2 gallons. That's actually pretty good mileage by today's standards in our cars. So again, let's go ahead and graph it. 0, 0 right here would be at the bottom. And we've got to figure out our scale. So as we go to the right, this will be our gallons. 1, 2, 3 gallons. Oops, we've got to put that. That's not a 2. That should be a 1. So let's put a 1 there. 1, 2, 3 gallons. And we could have stretched out those further, like every 2 marks if we wanted to. Okay, now going up the side, we've got to figure out how to do this. So if we do every mark as 10, 10, 20, 30, 40, 50. This could be the hardest part, is having to actually make a nice, neat scale. 60, and then lastly, but not leastly, 70. up that side. Let's go ahead and graph that then. We've got 0, 0, over 1 up 35, which is going to put it halfway between 30 and 40, and over 2 and up to 70. So there's our 3 dots that we've calculated in our little table of values. So now we just go ahead and graph that, sketch a line in between it, and there's our graph. So these are pretty straightforward. As you can see, it's easy to write the functions based on the words or the information given, and this should be a fairly straightforward, easy assignment for you, and it is a worksheet today. If you have any questions, let us know as we go along. And if you're at home listening to this, remember the worksheet can be found on the Today button. Thank you very much.